Assalamualaikum, and my name is Ahmad Syakir Mahmud Muhammad. My metric number is AE21029. Today I want to present the introduction. Induction motor, or we can call it as synchronous motor. It also a AC electric motor that magnetic field induct the current electromagnetically to produce torque. We need to use electrical condition to conduct this motor. Next, I will state the characteristic of induction motor. Firstly, the characteristic slip. Slip is a speed different from the synchronous speed, and its symbol is S, small s. Next characteristic is rotating speed and torque. Rotating speed and torque is inversely proportional for each other. When torque increase, the speed will decrease. The graph can show the relation between speed and torque. Next, I will state the technical problem of the induction motor. Firstly, the technical problem is motor can be easily hot, and induction motor have many power losses such as core losses, mechanical losses, and electrical losses. So finally, for this project intention is to explore the main characteristic and efficiency of induction motor during its operation with load change in simulation environment.
Assalamualaikum. My name is Nur Kamilah binti Abdul Wahid. My metric number is AE210031. So for the next part, we have methodology. In this part, we have two parts, which is block diagram and flowchart. So for the block diagram, process of modeling the induction motor, we have to choose a specific value for each parameter and variable for rate voltage, number of pole, rate horsepower, impedance, mechanical loss, core loss, and others. Next, process in obtain the main characteristic of the induction motor. In induction motor, the two main characteristics of induction motor is rotating speed and torque. Therefore, from task we know how to find the main characteristic of induction motor. So the last one is process of analysis in the model of induction motor. Induction motor can be analyzed by using electrical, mechanical, and thermal model. So in electrical model, we can determine the voltage and the slip. So for the next part is flowchart. The first one we have to start, and then we have to construct the model of the induction motor, and we have to input the value of parameter and variable, and we have to run the simulation of MATLAB. And from the simulation, we're gonna get the plotted graph. So for flowchart, this flowchart is to show the motor is run in MATLAB by using coding. Thevenin equivalent voltage and impedance can be calculated. Besides, the main characteristic of induction motor can be plotted by using MATLAB. By entering the value of the range that we have choose, the MATLAB will run the simulation and give the answer for the induction motor. That's all from me. Thank you.
It's our coding in MATLAB software to plot the graph. So first, this is our parameter, which is R1, X1, R2, X2, Xm. We face synchronous speed in RPM and synchronous speed in radian. So this is our parameter. So first, we need to plot the graph, which is torque speed characteristic. So our slip is 0.02. So this is the instruction we use. So first, the graph we got like this, which is this is the starting point and this is the maximum point. Okay, next, to plot the graph, power speed characteristic, same with the torque speed characteristic. We use the slip 0.02. And this is the first slip. We need to set to 0.001 to avoid divide by 0. So the graph for induction motor power speed characteristic. So this is the starting point and the maximum point. So next graph is induction motor characteristic with additional resistance. So this is our starting point and this is the maximum point. So this is the command we use, same as the torque speed. But we add the mechanical loss, core loss, and Michelinus loss to plot the graph induction motor torque speed characteristic with additional resistance. So next, for the power converted speed induction motor, this is the graph we got, which is this is the starting point and this is the maximum point. Okay, this is the graph for power output speed induction motor, which is this is an induction motor torque speed induction with 0% to 20%. This is the instruction we got. This is the slip we use. So it becomes like this. This is power output speed induction motor. And the last one is efficiency speed induction motor.
Assalamualaikum and a very good morning. My name is Nushifta binti Rosli and my metric number is DE210032. Today I'm going to present to you about manual calculation and also discussion of the result. So the first thing for manual calculation is we need to find the NSIN. The formula for NSIN is 120 times FE over pool. So the value that we got is 1500 ref per minute. The next one is we need to find the omega sin, and the formula is the value that we find earlier and times with 2 pi radian per 1 hour times with 1 minute over 60 seconds. And the answer that we got for omega sin is 157.080 radian per second. And the next one is we need to find the Thevenin equivalent voltage and impedance. And so to get the value of Thevenin equivalent voltage, we can use this formula, which is VTH XM over X1 plus XM times with V pace. And the value that we have to find first is V pace, which is we have to take the value of V line, which is 415 divided by square root of 3, which is we got the value of V pace, which is 239.6 voltage. And then we have to enter the value into the formula. So the formula for VTH is J20 over J0.85 plus J20 times with the value of V base, which is 239.6, and therefore we get the value of VTH, which is 229.832 volt. And then the next thing we need to do is to find the impedance, and the formula for the impedance is R1 times with XM over X1 plus XM power of 2, and then we just plug in the value and we got the value of RTH, which is 0.138. Okay, the next thing we need to find is the additional resistance, and we have to use the formula for Xmax. And as you can see, the value of Xmax is 1 and XTH is the value from the circuit, which is 0.85, and then we plug in the value into the equation and we obtain the equation, which is R2 is equal to Xmax time with square root of RTH power of 2 plus with XTH plus X2 power of 2, and then we got the value of R2, which is 1.925.
Okay, so for the torque speed characteristic of the induction motor, so the graph shows that the torque speed characteristic of the induction motor is using by MATLAB software. Starting torque for this motor is 14.437 Nm when RPM is 12. So the pull-up torque is minimum torque by C from the graph. It can define the curve as it increases. So next is pull-out torque, which means as breakdown torque, and for this motor is 1464 RPM and 252.514 Nm. Okay, next for power speed characteristic of the induction motor, the graph shows that the plot power speed characteristic of the induction motor using MATLAB software. From the graph, it shows that maximum value of output power and mechanical speed when using the selected parameters. Then the graph increasing proportional to the maximum speed power and mechanical speed at 1462.5 RPM and 0.2475 kW.
Assalamualaikum. My name is Noalia Tira binti Marazi and my metric number is AE210023. So for today, I will be talking about the result that we obtained from the MATLAB simulation, which is the graph. So the first graph is the top speed characteristic of the induction motor with additional resistance graph. So from this graph, the x-axis is the mechanical speed in RPM, meanwhile the y-axis is the induced torque in Nm. So we want to see whether the starting torque and the maximum torque changing when an additional resistance is added. So from our observation, the starting torque remains the same, which is 14.437 Nm, and the RPM is 12. Meanwhile, the maximum torque that a motor with an additional resistance can deliver while still maintaining the synchronous operation for this motor is at 1453.5 RPM and 250.645 Nm. So from our observation, we can see that when an additional resistance is added, the value of the maximum torque is slightly decreased in mechanical speed but increase in the induced torque. Next, for the second graph, the torque speed of induction motor with 0% to 20% slip. So this graph shows that the plot torque speed of the induction motor with 0 to 20% slip using the MATLAB software. So the same as before, the x-axis is in RPM, mechanical speed, and the y-axis is the induced torque in Nm. So we can see that the graph is increasing proportionally, whereas the maximum value we got is 253.246 Nm and 1495.5 RPM. So from our observation, this graph is increasing higher than before.
Next one is I'm going to explain the result for converted power versus mechanical speed for the motor as slip varies from 0% until 20%. So from this, we can obtain the value by using this formula, which is Pcon is equal to torque induced time with omega m. So from the circuit, we obtain the value from the graph. Pcon increased until it reached the maximum value, which is 38.7969 kilowatt when the speed is 104,061.9 Newton per meter. And then the Pcon will slowly decrease until 0 kilowatt at 1,500 Newton per meter. Okay. The efficiency of this conversion is represented by the motor efficiency rating, which indicates the percentage of the electrical power input that is converted into mechanical power output. The next one is I'm going to show you the result for P out versus mechanical speed for motor as slip varies from 0 until 20%. Okay. The rated power of the motor represents its maximum continuous power output capability under normal operating conditions. The formula that we can use to find this rated power of the motor is horsepower is equal to kilowatt times with 1000 over 746. And as you can see, we already set the value of horsepower, which is 50 horsepower. Therefore, we obtain the value of 37.3 kilowatt. And as you can see from the graph, we already done the simulation and we obtain the value of maximum P out is 37.9324 kilowatt. So as you can see, it's quite similar to the manual calculation that we already calculate.
Next, for the last graph we obtained from the MATLAB simulation, here is the graph of efficiency versus mechanical speed for the motor as slip varies from 0% to 20%. The efficiency of an induction motor refers to the ratio of its mechanical power output to its electrical power input. It represents how effective the motor converts electrical power into mechanical power. So the efficiency of an induction motor can be expressed by percentage and can be calculated by the following equation, which is the efficiency equal to P output over P input times 500. P output will be the mechanical power and P input will be the electrical power. So from the result, we can see here that the performance and efficiency of the induction motor is 38.7696% when the slip is at 20%, which is the typical full load slip at the induction motor.
Assalamualaikum and good morning. My name is Noira Masara binti Nordin with measure number A is210028. So I'm going to explain about the conclusion part. So basically, by completing our electrical machine project, we managed to enhance and improve our knowledge and skill to develop our induction motor model by using the MATLAB software. Besides, we also be able to gain more knowledge about the main characteristic and the efficiency of an induction motor during its operation with loop change in MATLAB environment. Other than that, we also managed to develop our induction motor model by using the MATLAB environment by choosing the suitable value for all the parameters and synchronized speed based on the range given. Based on the MATLAB environment, we managed to produce the graph of the torque speed characteristic of the induction motor and the graph of the power speed characteristic of the induction motor. Then we also be able to determine the starting torque, pull up torque, and also pull up torque based on the torque speed characteristic graph. And other than that, the value of the maximum output power also we be able to manage to find it based on the power speed characteristic graph. Hence, we also managed to plot the torque speed characteristic of the motor with the additional resistance. In conclusion, based on our project, we be able to understand the advantages of using simulation environment, which is MATLAB, to investigate the variety of value for all the parameters that related to our power system. Hence, we also be able to use and stimulate the simulation software wisely and know how to documentation it. That's all from our group. Thank you.